This is part 2 of our lecture over chi-square. In part 1, we talked about the 5 steps of hypothesis testing, and I gave you the equation for chi-square. So if you'll recall, the equation for chi-square is the sum of the f of O minus f of E squared divided by f of E. So let's talk about how we calculate those f of e's, or the expected frequencies. We have an example of a crosstab, and so the f of O, the observed, is the actual count in the cell. So 213 would be the f of O for cell A. So if we go ahead and we were to label each of these cells, we would have cell A, the f of O is 213. So now we need to calculate f of E, the expected frequency. And we're going to do that by taking the column total, so column total in, and we're going to times that by the row percent. Okay, so the expected frequency is going to be the column total times the row percent. Now the reason why we do this is because if men and women were the same, so if there were no differences between men and women or males and females in whether or not they find life exciting, then the number of people, or the percentage of people who find life exciting, should be the same for males and females. So we know that overall in our sample, 44.3% total find life exciting. And so it would, if men and women were the same, then men should be 44.3% and women should be 44.3%. And so we're just calculating how many would that be of our 425 total men. So we're going to multiply, so for cell A, we're going to multiply 425 times 0.443 to get our f of E for cell A. And then we would go on to cell B, and we would use our column total for women, which is 555, and we would still use the same percent though, 44.3%. And then we would move down to cell C, where we would use the column total, 425, and this time our row percent is going to change though, it's going to be 51.5%. And so we're going to do that for each of our cells. And then once we've calculated our f of e's, we can move on to the next part, which is to calculate our chi-square. Okay, let's go ahead and calculate our expected frequencies for each of our cells, and then we can go through and calculate chi-square. So for cell A, we're going to have 425 times 0.443. Again, we're multiplying the column total in times the row percent, and that's going to give us 188.28. And then cell B, we're going to have 555 times 0.443, which is going to give us 245.87. And then cell C is going to be 425 times 0.515, which is going to give us 218.88. And then cell D is 555 times 0.515, which equals 285.83. Then cell E is going to be 425 times 0.042, which is 17.85. And then cell F is going to be 555 times 0.042, which is 23.31. Okay, so now we have our F of E's for each cell. And so now we can continue on and we can calculate our chi-square. Okay, so now that we have calculated our expected frequencies, we can calculate our chi-square. And so we are going to put into our equation. So our equation here is chi-square equals the sum of the observed frequency minus the expected frequency squared divided by the expected frequency. We're going to do that for each of our cells, and then we're going to add them up because that's telling us to sum. So let's start with cell A. For cell A, our observed frequency is 213, and our expected frequency was 188.275. So we're going to subtract that, square it, and divide by 188.275. Now, I did round on the previous slide to 2 decimal places, and either way you're going to get a number that's going to be pretty darn close. You're going to be off by maybe 0.1 at the most, and that's okay. So overall, we're going to multiply that out, and we're going to end up with 3.13. And then we move on to cell B. And cell B, we have an observed frequency of 221. And then we have the expected frequency that we calculated. We're going to subtract and then square and divide it by the expected, and that's going to give us 2.51. And then if we move along to cell C, we do the same thing. We take our observed frequency, which is 200, we subtract the expected that we calculated previously, then we're going to square that, and then we divide by the expected, which gives us 1.63. So then we move to cell D, and for cell D, we have an observed frequency of 305, and we're subtracting 285.825 or 83 if you rounded. And then we're going to square it, and we're going to divide by the expected, and that's going to leave us with 1.29. Cell E, we have an observed of 12 and an expected of 17.85, and so we're going to square that and then divide by the expected, which gives us about 1.92. And then we take the cell F, our last cell. The observed was 29, the expected is 23.31. We subtract and then square and divide by the expected, which gives us 1.39. So then we're going to add all of that up. And so we've got our 3.13, 2.51 plus 1.63 plus 1.29 plus 1.92 plus 1.39, and that's going to give us 11.87. And that is our chi-square value. That's what we're looking for in our calculation of chi-square. So now what do we do with this number? We move on to step 3, where we're going to calculate degrees of freedom. So degrees of freedom for ANOVA and for t-tests really were about the size of the sample. They were really about n. But the degrees of freedom for a crosstab is about the size of the crosstab. So how many categories of each variable do you have? And the degrees of freedom comes from this idea that once you know the values of a certain number of cells, then the values of the rest of the cells are determined. So in this case, we have 6 cells. If I know the values of 5 of those cells, by process of elimination, I can figure out the value of the 6th cell. And that's where kind of this idea of degrees of freedom comes from. For degrees of freedom is here. It's R minus 1 times C minus 1. And here, R is the number of rows that you have in your crosstab, and C is the number of columns that you have in your crosstab. So for our example, we have 3 rows, exciting, routine, and dull, I believe are the categories. And then we have 2 columns, male and female. And so we have 3 minus 1 times 2 minus 1, which gives us 2 degrees of freedom. Now we're going to go to step 4, where we're going to look up the distribution of the test statistic to find its critical value. And so we are going to stick with the 0.05 level of probability. It's the standard, like I said, it helps us minimize type 1 errors as well as minimizing type 2 errors. And so we are going to use that level, and we're going to use the table that's been distributed to you through OpenClass, and also it's in your textbook to calculate or to find that critical value. So we're going to look down the column that says DF, down degrees of freedom, and then over to the 0.05 level of probability to get our critical value. Once you have determined your critical value, you are going to make a determination. Decide if you are going to reject or fail to reject the null hypothesis. And so in this case, after we looked in our table of chi-square values, we found that the critical value is 5.99. And so just like with t-test and ANOVA, if our chi-square is greater than the critical value, we reject the null. And if our chi-square is less than the critical value, we fail to reject the null hypothesis. So in this case, we are going to reject the null hypothesis. So here's how we'd interpret chi-square. We would say that we reject the null hypothesis, that there are no differences between sex and finding life exciting. In other words, the association is significant at the 0.05 level. Now, the one thing missing from this interpretation is that we would need to say something about the actual value of chi-square. So with a chi-square of 11.87, we reject the null hypothesis. So that's the only thing that you would need to add to this. So that is how you would interpret chi-square and calculate it by hand. I want to take a second to look at the SPSS output. So I've calculated chi-square using the same data that we had for that cross tab that we just looked at. And so our chi-square value, this first number, this top number that's circled in red, 11.994, that is what SPSS calculated as the chi-square value. And then over here circled in green, this 0.002, that is the significance level. Basically, we want this to be less than 0.05, and that is good. That means that we reject the null hypothesis. So we want that SIG number to be less than 0.05. So that about does it for chi-square and how to interpret and how to calculate.